This is a presentation about 10 minutes that was given at the Entomological Society of America. So we have this ready-made presentation on the mosquitoes on the research topic that you will need to present. So I'm going to just slightly edit this and walk you through the slides, and then you can take this and you can build it however you want to build it or modify it or change it to address the needs of Strahl and Hess. So here's just the title slide. I added in Strahl and Hess, and I left Kyle because he put this together, and myself at Auburn, but feel free to change however you need to change it. So this is an overview of the talk. We'll talk about background, introduction, and the research, bite blocking, and engineering comfort in textiles. So here's the first slide on mosquitoes. Mosquitoes are a global problem. Mosquitoes vector many different diseases like yellow fever, dengue virus, chikungunya virus, Zika virus. So many viruses. Many of these viruses are deadly. Yellow fever and dengue can kill people. Malaria is not a virus, but another horrible disease that also kills people. All these are vectored by mosquitoes. Here's a map of incidences of dengue. So 390 million cases per year. It's about 1 million people die each year from mosquito-borne diseases. But the point of this is that many, 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 many more actually get infected and have a horrible experience with these diseases. So 390 million cases a year. Most of the mosquitoes are located in the tropical regions that are spreading dengue, but mosquitoes spreading diseases are in fact all over the world. So even more than this, although the worst ones are in tropical climates. Okay, so modern mosquito protection. How do people protect themselves against mosquitoes? So one of the reasons that the current state of the art is less than ideal is because it involves putting chemicals all over yourself. So one of the most common ways is people will put DEET on themselves. People do not like that. Another common way is they will have what's called impregnated clothing. So they will impregnate clothing with permethrin, which is an insecticide. So people don't like that because they don't like to wear insecticides and chemicals on their body or in their clothing. At night, people can protect themselves with bed nets. So these are in third world countries where perhaps they don't have windows or effective screens on their doors. So the point of these current controls is that there remains a lot to be improved. People don't really like sleeping under the bed nets, and they don't like being inundated with chemicals, which introduces the research question, can we mechanically block mosquito bites without insecticides using textiles? So this is ongoing research in our lab. The first experiments we did were we collected a bunch of different textiles that people wear. And we also collected textiles that advertised as mosquito bite blockers, including rhinoskin, which is D right here. We looked at them under the microscope, and what you can see in this data is that if you look at modern textiles, these are all different weaves and knits of modern textiles. They all have these holes. Okay, mosquitoes can bite through these holes, and D and E are actually advertised as mosquito bite blocking textiles, but they're filled with holes. So then we tested these different garments that you can buy for bite blocking. Here's the data for that. So the way to read this graph is that the y-axis is number of bites you get. So the experimental setup is we put 20 females in a cage, you put the textile around your arm, you put your arm in the cage, and you quantify how many bites you get after a period of 15 minutes in the cage. So if you just do this with the bare arm, which is the negative control, you get about 16 bites per arm. Everything over to the right then is testing different weaves or knits. So we're testing weaves here, knits here. None of the weaves we tested blocked. What we found with the knits is that the knits were more variable. Some had very low blocking, but some had high blocking. So as this knit right here, which was actually jeggings. So what this preliminary data allowed us to discover was that there are knits that can block mosquito bites. So then we got really interested in knitting. So this is when we bought the Stoll flatbed knitting machine. And the premise of buying the Stoll flatbed knitting machine was that it's a CNC knitting machine, so you can use the computer to code in different knit geometries. And so we successfully knitted 8 different knit geometries and tested them for mosquito bite blocking. So here's standard single jersey. On the right, you have the knit diagram, and on the left, you have the actual microscopy of the actual textile we produced. And all this is while utilizing the same type of yarn. So we're controlling yarn, holding yarn constant, and we're testing different geometries, including single jersey, tubular, alternate jersey, interlock, jersey skip, full rib, full cardigan, and half cardigan. One important thing we noticed right away is that a heat treatment, or essentially putting the textiles in the dryer, causes them to shrink, which is standard. So here you can see a microscopy image of how the textiles actually shrink. And actually that shrinking is key to the blocking. So here's another graph of the 8 knits that we knit ourselves with the CNC knitting machine. And one of the early important discoveries was that if you heat treat these, if you heat treat the interlock knit, it increases its blocking. So here's the 8 knits, all heat treated. The only one that blocks is interlock. So what we felt that we had discovered at this time was that interlock knit has a property that its geometry is particularly good at blocking mosquito bites in comparison to the other knits, which essentially don't block at all. So after realizing A, that there were knits that we could make ourselves that block, and B, there were methodological practices like heat treatment that could increase blocking, we started to research what are the other ways that we could engineer blocking or increase the blocking capability. So the 3 that were discovered that we published on were fiber diameter, spandex content, and stitch length. So here's one example data where if you increase fiber diameter, so you take the same knit, but you increase the fiber diameter. Okay, so here is 3 single jersey knits, and we're going from a thin fiber, intermediate fiber to a thicker fiber. The thicker fibers block. So they're expanding, they're filling up those gaps, and they're blocking. So one way that you can engineer blocking is you increase the fiber diameter. The second treatment we explored was spandex content. So here's the same knit, and as you increase the spandex content, the spandex has internal compression pressures that will squeeze together the knit. And so as you take a knit from 0% to 2.5 or 3% spandex, you will begin to see the blocking effect. Now, this is not to say that all garments with spandex block. They don't. So I want to be clear. Not all garments with spandex block. Spandex is not a catch-all that gives you blocking. The point of all these is that each textile can be methodologically optimized to get blocking. And spandex is one of those factors that plays into that. This is a third parameter we discovered that helps to increase blocking. This is actually a parameter on the CNC knitting machine where you decrease the stitch length. So that's how much the needle is pulling through each knit. And if you decrease the stitch length, the knits get tighter and tighter and tighter, and they tend to block more. So blocking goes down as stitch length decreases. Okay, so by this time we had essentially proven that knits can block, but they have to be optimized. And we discovered the variable parameters that will cause blocking. So then the problem is, okay, you can make these blocking textiles, but we were making these with polyester. They were not very comfortable. Then the question was, can you engineer comfort? So we tested comfort. This was Alexa's work with a few different measures of comfort. One was a 9-factor perception test. So we asked people to feel the textiles and rate it according to different perceptions. We also tested heat loss, air permeability, and water wicking. Okay, so we have these tests for comfort. Then we tested a bunch of different fibers. So we tested the interlock knit with polyester, nylon, black spandex, recycled spandex, spandex coated with nylon. So these are some of our earlier comfort data where we're comparing some of the blocking knits that we either found or are able to produce. So green are the blockers. Red is kind of like a control that we consider a control comfortable garment, Under Armour. And one of the things we notice is that one of the blocking garments is not statistically different in comfort from Under Armour. So the point of this figure is that it is possible to make clothing that is just as comfortable as Under Armour, but also blocks mosquito bites. Here's heat gain. All of our 3 blockers are not statistically different from Under Armour. So the point here is that you can make blocking garments that are just as comfortable in hot weather as Under Armour. Air permeability, ditto. The interlock knit here is not statistically different from the Under Armour. So essentially, these are just different comfort measures. And in each measure of comfort, we demonstrate that it's possible to engineer a textile that is equal in comfort to Under Armour that also blocks. Okay, so here's a test where we're measuring both comfort and bites of interlock made up of different fibers. So we're trying to engineer both comfort and blocking in the interlock knit. So on the left, this is the comfort graph where we're looking for what's the most comfortable interlock fiber combination. Higher scores are more comfortable. And so we discovered that the spandex coated nylon is the most comfortable permutation that we've tested of the interlock, which is not statistically different in comfort from Under Armour. So it's very similar in comfort to Under Armour. If you look at that same textile over here on the right with blocking, that spandex coated nylon in 3 replicates had 0 bites. So it's completely blocking. So the point of this figure, this combinatorial data, is that textiles can be engineered to be super comfortable and also block. Okay, the rest of this stuff is probably not necessary. Okay, I'm gonna try to edit this video. This should give you enough material that you can pull from. So some of these graphs, if you want to use just a particular graph here or there, or there's something you want to point out, you can pull the graphs from this PowerPoint and put them into your own, or you can use the slides and put them in your own. If you need anything from me, just send me an email and I will immediately help. Okay, so I also just wanted to show you this preprint because this is a publicly available publication that we've put out there. And this is currently under peer review at Communications Engineering, which is in the Nature Publishing group of journals. So this is being reviewed right now by a very highly respected brand of scientific journals, and it's likely to come out in the next 2 months, which should blow up the story. And there are a few other final points from this paper that I didn't include in that presentation that I just kind of want to go over. So in this figure, over here in F, what you're looking at is you're looking at a heat map of where clothing clings to the skin. And the point here of this, one of the criticisms you should expect when you present this data is people think that people think that clothing blocks mosquito bites, and it doesn't. Okay, what you need to express to if there's somebody who's skeptical is that sure, clothing will block if it's away from the skin. Okay, if it's away from the skin, but much clothing nowadays is either designed to cling to the skin or clings to the skin in certain areas. So in F, what you're looking at is a few different garment types, and all the red parts are where either the skin is exposed or it's clinging to skin. And the main point of this is that all clothing, no matter what it is, clings to the skin in certain regions that mosquitoes can find, and mosquitoes can bite through this. So if you look up here, here's a long sleeve shirt. One of the most common misconceptions to protect yourself from mosquitoes is people say, wear a long sleeve shirt. Okay. The problem with that is if you look at this data, the long sleeve shirts cling to the upper back in these areas, and mosquitoes are particularly attracted to those regions, and they go to those regions. So in one of the final figures here, if you look at this E, this is a heat map of where mosquitoes land when they bite, and on the back they love to go to the upper back, and this is the region where clothing clings to the skin. Okay, so the point is that standard long sleeve shirts do not block mosquito bites, and they cling to the skin in areas where mosquitoes like to go bite. Okay, I also have this very important video that we have captured, this video data that proves this, that mosquitoes can bite through clothing. So here on the left, we have Under Armour. Here on the right, we have a blocking knit. And I'm going to send you this link. And so if anybody doubts that mosquitoes can bite through clothing, just show them this 15-second video, and it will immediately show them that mosquitoes easily bite through things like Under Armour. Good luck.